This question is given in GATE 2012. So let me read it out for you. Consider the function f of x equal to sin x in the interval pi by 4 comma 7 pi by 4. The number of locations of the local minima of this function are. Now they are talking about the local minima, and also they are asking about how many points you are going to have local minima, right? In order to solve this, you are supposed to find out all the points at which we are going to have local minima. Now definitely those points will be one of the stationary points. So in order to find it, you just find out all the stationary points, and one of the stationary point will definitely be, one of them or many of them will definitely be local minimum, right? And after that you need to even check at the extreme values. Extreme values means since the range is given, you have to find out the left boundary and the right boundary, and at those points also you need to check whether it is a local minima or not, right? Now while defining the definition of local minima, I told you to look at the neighborhood both to the left side as well as the right side. But when you are looking at the extreme points, if you take the left extreme point, just look at the right neighborhood of it and decide whether it is a local minima or not. And similarly, if you are looking at the right extreme value, then look at the left neighborhood of it. Okay, now I'll show you what I'm explaining, I'm telling you here. So first thing is find out all the stationary points. So how can you find out the stationary points in the range? Find out f of x and equate it to 0, right? So f dash of x, so f of x equal to sin x, find out f dash of x and equate it to 0. I'm trying to find out all the points at which the tangent is having a slope of 0. See, what does it mean? F dash of x equal to 0 means I'm finding out the points at which the slope of the tangent is parallel to the x-axis, which means slope of the tangent is 0, or the tangent is parallel to the x-axis. Now if I find out, then I found out that at x equal to pi by 2 and 3 pi by 2, in this range, you should also keep this range in mind. In this range, these are the only 2 points for which the tangent is 0, slope of the tangent is 0. Therefore these two are the stationary points. Now one of these 2 points may be, there is a chance that one of these 2 points may be, or both of the points may be local minima. So let's find it out. In order to test it, we can find out f dash of x. Now if I find out f dash of x, at one point I got less than 0, and other point I got greater than 0. So whenever it is less than 0, this is the maxima value, so rule it out, which means pi by 2 is ruled out, right? Now what is remaining? 3 pi by 2. At 3 pi by 2 I got greater than 0, which means definitely here I have a minima, right? So since I have a minima, then I can say that this is one of the points at which we have local minima, right? And now I have to find out whether at the extreme points we are going to have local minima or not. So it will be better if I show you with a graph whether it is having a minima at the extreme points. Let's see the graph there. Here, now if you see this, so this is the extreme point. One extreme point is pi by 4, right? So which means this is the pi by 4, right? And the other extreme point is 7 pi by 4. Now if you observe this, if you are talking about the left extreme, just compare the value of that point with the points to the right neighborhood, which means just find out the point to the right of it. At all the points to the right of it, they are greater than the value at this point, right? So at this point the value is 1 by root 2. Now if you take any point to the just to the right of it, in the right neighborhood, they will be greater than this. That is why at this point it is minimum, right? So it is called as local minima. So when you are talking about the left extreme, look at only the right neighborhood. When you are talking about the right extreme, look at only the left neighborhood. Why? Because the function is defined only between those interval, or we are caring only about that interval. We don't care about the points which are to the right of it in this case and which are to the left of it in this case, right? Now similarly, if you want to test whether it could be a minima or not, just compare it with the values to the left of it in the left neighborhood. Now in the left neighborhood you can clearly see that the values are less than this, and so it cannot be minimum. But here to the right of it you are seeing that the values are greater than that, therefore it can be minimum, right? Therefore we got this point also as a local minima, and also 3 pi by 2 as one of the local minima, right? So these 2 points are the local minima. Got it? Now what is the global minima? If you find out all the points, all the critical points and all the boundaries, I mean all these extreme points, and if you find out the minimum among them, that is going to be global minima, right? Global minima is going to be this one, but these two are local minimas. Got it? Okay. Now one more way you can identify the local minima and all the points of local minima is one other shortcut is just see the function and see where the strictly increasing behavior is going to start. If you look at it from this point, from pi by 4 to pi by 2, the function is strictly increasing, and therefore the pi by 4 must be a minimum in that interval, isn't it? Therefore it is a local minimum. And again, if you see this, from here to here it is strictly decreasing, and again from here it is strictly increasing, right? Therefore at this point the increasing behavior has started, and so you can say that this is the again a local minimum, right? That is one other way of looking at it. Now look at the answers. Pi by 4 and 3 pi by 2 is the answer, right? 2 at pi by 4 and 3 pi by 2. Therefore D is the answer. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.